what we're going to do on this test is antibiotic sensitivity. In order to do that, we need a TSA plate and we need a bunch of antibiotics on little filter paper discs. And they're actually impregnated with a given amount of an antibiotic, and the discs are marked. In this case, even though you can't read it, this one says VA 30, which stands for 30 micrograms of vancomycin. We're going to put these onto the plates. The tube normally shows up in a dispenser like this. Right? The dispenser holds 6, 3 on this side and 3 on this side, of these dispensers. When pushed, this will dispense a set of filter paper discs onto our plate. You're going to take a plate, you're going to take an organism, you're going to flame your loop, cool your loop, and spread the organism over the entire surface of the plate. Just keep going until you've covered the plate completely. You will notice that I've turned this multiple times to keep going back and forth. Oh yeah, don't talk on the plate while you're doing it. And then flame your loop, cool your loop. That part's done. All right? Once you're done with that, put it lid down and write on the plate what the organism is and your initials. Do it now, because once you get the filter paper discs on, you got to leave it right side up. If you don't leave it right side up, the discs fall off. And if the discs fall off, it doesn't work so well. Once you're done with that, you need to apply the discs. And how are we going to do that? We turn it right side up. We take the lid off. We set our dispenser right over the top. Remember, I took the lid off. Otherwise, the discs just wind up on the lid and it does us no good at all. Then I just simply push down, release, remove the dispenser, put the lid back on. You can see our discs sitting on here. And we will simply incubate this right side up. In this one here, you will notice that we don't have anything growing except for one big fuzzy, one big mold growing on this. Well, one big mold growing on this isn't going to help us much. This plate was not inoculated at all. It was just used as a demo like the other one. The thing is, all of these are antibacterial antibiotics, and obviously, considering the fuzzy's grown right on top of a disc, they don't work so hot on fungus. So, in order to do something against fungi, we would have to do this with a bunch of antifungal discs instead of antibacterial discs. Now, here's what one winds up looking like if we can zoom in on it just a little bit. This one's been incubated. And what you'll notice is, in this case, this one that says AM10 or ampicillin 10 micrograms, it doesn't affect it at all, does it? The organism is resistant. And as we go around, you can see slightly bigger areas, clear areas around the outside. The clear areas are zones of inhibition, as they're called. And one would think that the bigger it is, the better it is. Well, not necessarily. Some of the antibiotics are smaller in size than others. The smaller they are, the better they move out from the disc out through the media or out through the agar. So sometimes the bigger zone doesn't mean that it works better. It just means that it's smaller. Maybe this one happens to be a very big antibiotic, and it actually works better than this one here, which might be a very small antibiotic. But in order to determine whether the organism is resistant or sensitive, you just simply measure the distance from the disc across the clear area, and then compare it with a table in your book that gives you what the standards are supposed to be. And you can determine antibiotic sensitivity or resistance to various antibiotics. Same way they do it in the lab. So you may not be doing this in a lab, but you're going to be getting the report sheet out on this. And it might be nice to know what's going on.